Well, we're going to keep on working on the main definitions and main magnitudes that we need for motion. We end up here in the homework, and now we're going to see speed. You have all used this word, but now we are going to say it scientifically. So we're going to say first that this is not a normal magnitude, it's a vectorial magnitude. As we have seen, it means that we need an arrow to represent it. But we're not going to enter into detail here. Just know that this is a vectorial magnitude. You will study it deeper in other courses. So it's a vectorial magnitude, and the unit, as you may know, because you know kilometers per hour, but in the international system, that is meters per second, so m divided by s. Okay, that's the international system units. But this is a very kilometers per hour is a very common unit in our daily life. So we need to use conversion factors to work with everything. And I have done a video here to explain all the conversion factors in detail and with all the steps and so on, and in Spanish actually. And so you can watch it because now I'm going to be fast because it's not the topic of or the goal of this lesson to do conversion factors. But again, watch this video if you don't remember how to do it. Yeah, we saw in class, we saw it in the beginning of the course, and there were some steps, and because the other video is in Spanish, I have put everything in Spanish. These are the steps, and if you read them, I'm sure you remember them, but I'm going to just go a bit quickly on how we do it. If we want to change 90 kilometers per hour to meters per second, first we write exactly what we have, the exact thing we have. So 90 kilometers per hour. Then we put one fraction for every unit we need to convert. In this case, we need to convert kilometers to meters and hours to seconds. So two fractions, one fraction, another fraction. And the next step is that we need to place the same units in the opposite part of the fraction. So if kilometers is at the top, then we need to put it at the bottom, and if hours is at the bottom, we need to put it at the top. Don't mix distance with time. So we have a fraction for distance and a fraction for time, but do not put kilometers and hours together because these are conversion factors, and you can only convert kilometers to meters. You cannot convert kilometers to hours. So please, in the fraction, use distance or time, but do not mix them. And here we need to put the conversion that we need. And you can put that 1 kilometer is 1,000 meters, or you can put that 1 meter is 0.001 kilometer. It doesn't matter as you put it, because the result is going to be the same. I think it's easier if you place the 1 in the biggest unit, that's kilometers, and then you make the conversion. Why? Because when you're using powers of 10, like with kilometers and meters and grams and liters and so on, that's easy. But if you want to do the same with hours, it's very difficult to know the 1 second is 0.00 whatever hour. So, but we all know that 1 hour is 60 times 60 seconds, so that's 3,600 seconds. Then we cross the same units, and we need to have in this step the units that are asked, and we do the calculation. So we put everything that is on the top, and everything that is on the bottom, and then we just do 90 times 1,000 times 1 divided by 1 times 3,600, and then we have that this is 25 meters per second. That's how you do it. And this is the same, but with meters per second to kilometers per hour. And the only thing is that now meters have to be at the bottom and seconds has to be at the top. So you change, and kilometers are at the top and hours are at the bottom, because the rule is that they need to be, the conversion factors need to be opposite to the data. And yeah, so the same again, for more information you have this video, but because this video is like 15 minutes long, I'm not going to do much more here. So we were seeing that speed, the unit is meters per second, and that's why we were seeing how to change from kilometers per second to meters per second, because this is the important unit, the international system unit. And we're going to define what the mean speed is, and that is the distance traveled. You remember from previous videos, the distance traveled is the path length, so the kilometers or the meters, the distance you have really walked or driven or whatever. So again, is the distance traveled divided by the time required to travel it. So that's the definition. So the velocity, the mean speed, Vs for velocity, but in normal life we use speed, but you can say also velocity. And M is because it's mean, so media, velocidad media. And distance traveled, we're going to say that's E from a space, so the space traveled, and the time required to do it. But it's different from the instantaneous speed. That's why we just call speed without any other thing. That's the instantaneous speed. And that is, as the name says, is the speed that the object has in every instant. You're going to see this in third of ISO, so I'm not going to work in this definition anymore, but we are just going to work with mean speed. And we're going to see an example. Here we have a problem solved. A cyclist rides at 8 kilometers per hour if the cyclist departs from a position of 1.5 kilometers to the left of a house that we use as a reference, that's our reference, remember that, and moves to the right. Where will he be after 1 hour? So again, I need you to organize the problem with data, conversion of units, formulae and calculations. And I want to see this because I'm going to do it like that. So first, let's do a bit of a drawing to understand what is happening. So the reference frame, and I put the axis here, is the house. And we have a cyclist that is to left of the house. So left of the house. And at some point it's going to be at the right of the house. So after 1 hour, where is it going to be? So relative to the house, not relative where he was in the beginning. So data, what do we have? We have that the initial position is 1.5 kilometers to the left of the house. If you remember, if we in maths, when we put this axis, and this is the 0, when we are plotting some points to the left, we say these are negative numbers because the positive numbers are to the right of the 0. So if we are 1.5 kilometers left to the house, that means that we represent it with the minus. So we are at minus 1.5 kilometers, okay? Because we are at the left of the 0. That is our reference, the house. We also know the speed. So the mean speed, the mean velocity is 8 kilometers per hour. And they ask us the final position. So xf from final position. That's the data. Okay. The formula I'm going to use, the only two that I have for speed, that's the one for velocity, that is space over time, and the one for the distance traveled that we saw is final position minus initial position. Those are the ones that I need. I'm going to need this in the end, because I want to know, that's what I want to know, the final position. So the calculations first, I'm going to know what the E is, and if I substitute in the formula, then I know this is 8 kilometers, because I know it, because that's my data. Then I know that time is 1 hour. Oh, I forgot to put here the time is also something that I know is 1 hour. And if I want to have E, what I'm going to do is pass the 1 to the other side, multiplying, and then 8 times 1, that's 8. So E is 8. And then I have this other formula. E is equals to the final position minus the initial position. And I have the final position, I have the space, the distance traveled, that is 8 kilometers. And I don't know this one, but that's the one I want to know. And so minus, and then this one, I have said that is minus 1.5. So minus is going to turn to a plus sign, and if I move it to the other side, it's going to go with a minus. So XF is 6.5 kilometers right to the house. That's the whole thing, and that's the everything, so that you can see it in colors. And these are the homework for next day. See you in the next video.